part C of question 14 is somewhat trickier than parts A and B. Well, so let me show you how it can be done. So, so here we're supposed to differentiate zeta 2 times with respect to theta, right? So recall that we already found in part A that the first derivative of zeta with respect to theta is r times minus zx sine theta plus zy cosine theta, right? Okay, now, so what makes it hard, right? So what makes it hard is that now we've got to differentiate with respect to theta again, right? So because we need to find the second derivative with respect to theta, and this is the first derivative with respect to theta. And when we differentiate the with respect to theta again, well, r is independent of theta, right? So because r and theta, they kind of they sit in the same kind of coordinate plane, so they're independent variables. But zx is in fact a function of um, r and theta, because imagine that f is, or z is, some expression in x and y, right? So if you differentiate this with respect to x and then substitute r cosine theta for x and r sine theta for y, then you will get yourselves an expression in r and theta. So which means that zx is in fact a function of r and theta, and its derivative with respect to theta is not really zero or anything. So we have to differentiate it. And so what I want to say is that since we want to differentiate this with respect to theta, it means that we've got to apply here and here the product rule. And this product rule is going to involve z differentiated with respect to x and then with respect to theta, and z differentiated with respect to y and then with respect to theta, right? So let me do this too somewhere here. So the z, partial derivative of z with respect to x differentiated with respect to theta. According to the chain rule, this is, how do we do this? So we first differentiate z x with respect to x times partial derivative of x with respect to theta, right? So plus we take our zx, then differentiate with respect to y, and then times the derivative of y with respect to theta. Okay, so zxx, we know it's 1. So this 1 times x theta. So this is my x. Its derivative with respect to theta is really minus r sine theta plus zxy. We don't know what zxy is, so we can't really simplify it any further, times the partial derivative of y with respect to theta, and this is r cosine theta. All right, and let me insert it here. What we get is really r times minus sine theta plus z xy cosine theta. Okay, so what is now zy differentiated with respect to theta? Basically, because of the same logic, this is going to be zy differentiated with respect to x times x theta plus zy differentiated with respect to y times y theta. All right, so what is that? So zyx is really the same thing as the zxy. So what is the derivative of x with respect to theta? Right, so it's minus r sine theta. And so zyy is 1, we know this. So plus 1 times, and what is y differentiated with respect to theta? It's just r cosine theta. Right, so what we get in the end is, let me erase this because I need some space here. So what we get here is, I guess we can take out r, and this here is going to be cosine theta minus zxy sine theta. Okay, so let me do let me differentiate z theta with respect to theta again, right? So z theta theta is going to be, r is independent of theta, so I can just take it out. Now minus zx sine theta, I've got to differentiate it according to the product rule. Right? So first I'm going to keep the minus sign, and I guess probably I just uh, use the parentheses. Now first I need to write zx differentiated with respect to theta, which is whatever I just calculated, right? So it's r minus sine theta plus zxy cosine theta, and it should be times sine theta plus zx times the derivative of sine theta with respect to theta, and that is cosine theta. Cosine theta. Okay, so now I've done this, I've differentiated this. So plus zy differentiated with respect to theta, and it's here. So this is r cosine theta minus zxy sine theta times cosine theta and plus zy times the derivative of cosine theta with respect to theta, which is, right? So now I've got to differentiate cosine theta with respect to theta, and the derivative is minus sine theta. Minus sine theta. Okay, then I guess I have to expand it, but what helps here is substituting the actual values. All right, so let me do this. So notice that zx and zy equals to 1. So zx is 1, zy is 1. So it kind of makes things easier to calculate. So another thing that we know is that r is 2. So this r is 2, this r is 2. Okay, cool. And theta is pi over 2. So which makes cosine theta equal to 0 and sine theta equal to 1. All right, so this cosine theta is really 0, this sine theta is really 1, this cosine theta is really 0, this sine theta is really 1, this cosine theta is really 0, which is super convenient. This cosine theta is 0, this sine theta is 1, and this sine theta is 1. Okay, so let me see what kind of disappears from here. So zx disappears, well, actually cosine theta is 0, so it just disappears. Now, this whole thing becomes just 1. Okay, so cosine theta here, so this whole thing disappears very conveniently. Okay, so cosine theta here disappears. So the final result is, so this r is 2, is I guess 2 times negative 2 times negative 1 plus 0 and minus 1. So which is, I guess, 2 times 1, which is 2. Okay, so the final answer is just 2. So let me check if it is the same as the model answer, and yes, it is the same as the model answer. Alright, so that's how we do this question.